Hello, everybody. Welcome to our DME product discussion. Today's topics, we're going to be discussing our new ACCUALIGN lifters and our Tri-Lock lifetime parting line locks. My name is Jeff Sarnicki. I've been in the trade since 1988. Started out as a mold designer, migrated over into sales and some product development and program management within the mold component industry. With that, I'd like to introduce our newest member to the DME family, Joe Hansen.
Hi, everybody. I am Joe Hansen, and I am the new kid on the block here at DME, just starting in January. Even though I'm the new kid on the block, I've been around the block a few times. I've been in the plastic injection and die-cast industry for over 40 years. I'm going to try and share some of my experience today. I am really excited to be here. I'm super excited because we got some new products. And I can tell you, over the years, sometimes you get a little bored. We're not going to be bored today because we're introducing you to our ACCUALIGN lifters and our lifetime LT series parting line locks. Let's go ahead and get this thing started.
Moving on.
We have technical difficulties already.
There we go.
No, there we go. Here we go.
So the term DME or equivalent, it's commonly seen in a lot of the different tooling standard guides that are out there within our industry. DME has been around for over 75 years. We were the first to standardize mold bases and mold components as off-the-shelf standard type components. Going forward, we want to see DME only as we introduce these new products. And we're going to start talking about them now. If you'd advance the slide, please. Slides versus lifters, the age-old questions. Which one do you choose? What do you think, Joe?
Well, I figure you should give the age-old question, the age-old guy. See that face? That face has spent a little bit too much time around a Bridgeport spindle, I can tell you that. Anyways, the age-old question that we're going to talk about today is lifters versus slides. We say lifters, and we're going to say ACCUALIGN lifters. And hopefully by the time we're done with this webinar, the ACCUALIGN lifter page is going to be your screensaver on your computer so you can remember that you want to go with the ACCUALIGN lifters. Let's just move on. And we're going to show you a couple examples because there might be some people online who don't fully understand what we're talking about. So we're going to show you a couple of simple pictures. This first one here shows the slide action that we're talking about. The orange portion of this picture up toward the top is the slide or side action. And what that's going to do, it's going to release the trapped plastic of the yellow part when the mold opens. The angle pin will drive the slide back and it'll release the plastic. And then we'll just go on to the next example where we're going to show you the lifter, where the lifter is shown in blue. The steel is blue. The part up on top is shown in orange, and you can see just a little bit of trapped plastic on the left-hand side of that part. And when the ejector plate comes forward, the lifter will go up on an angle and it'll release that internal undercut from this. So just a real couple of quick slides for those who are less experienced and want to know what we're talking about. So next we're going to show a little video that we put together that's going to show you these slides in action, and Jeff's going to talk about it as we go.
So this video is going to introduce the new ACCUALIGN lifter. And within our system here, there's three key features that make our system unique compared to other products within the market. And as this video plays here, I'm going to speak to two of them. The third will be on the other slide. The first component, I'm going to start from the bottom of the assembly, is our slide shoe or ball retainer. It is a D2 material, hardened to 60 Rockwell. It's got a precision wired slot, and we leave a generous clearance within that slot so the ball adapter can move within the component. Not only does it move, it actually provides a floating motion. So that's the first feature. Hey, Scott, could you pause right here for me? The second, within our ball adapter, which is a two-piece construction, we use a proprietary process to combine the actual lifter holder to a C2 carbide ball that's extremely hard. And within the slide shoe mechanism, this allows for a floating condition. Go ahead and continue, Scott. And I'm going to ask you to pause right there. So in addition to that, if you could pause, Scott, thank you. In addition to that, we have a dovetail feature that not only holds the rod and the lifter blade to the holder portion of the ball adapter, but it also acts and provides side-to-side motion. So you have two features here that allow for auto aligning within our lifter system. And you can continue, Scott. Thank you. I'm going to let this animation play out. So here we're illustrating our lifter rod. Next few slides will show the lifter blade. And in addition to our lifter blade, we also provide roller guides for added strength so that the lifter blade itself will not flex. And this picture is illustrating on the blade. You can see that the part geometry is cut right into the solid blade. On the right, on the left, is a more common lifter design that you would see in automotive applications. And in the near future, we're going to have the ability to provide cooling into our system. Let this wrap up. Okay, moving on.
As you just saw in the video, there's a couple options that we have parts in stock of the ACCUALIGN lifters. The one on the left is a round lifter rod, and as you saw in the video, the one on the right on this screen, it's called the lifter head, the lifter blade, the lifter bar. There's several different things that we can call that. They're all available and in stock, along with all the components shown here. And Jeff's going to tell us a little bit more about those components as we move through the presentation here. So let's go ahead.
Hold on, I want to speak to the ACCUALIGN lifter rod application. But I had mentioned in the previous slide, there's a custom lifter head there that's pretty common within the automotive world. In addition, we have our gasket and our keeper key that actually fastens the rod into the lifter itself. That's a third portion or third part that makes us unique as far as our auto alignment features that are offered within our system. So as the lifter rod is installed into the lifter head, that gasket will compress about 18%. So as the keeper key is engaged and it fastens, it allows that lifter head to float. So as the ejector stroke goes forward and returns, if there's any kind of misalignment, maybe you got a little heavy or some stock on one of the sides of the lifter as it's trying to recess back into the pocket, that will automatically start the auto alignment process from the head down to the rest of the components within the lifter system. We can go to the next slide. Moving on. So just to talk about some of the components, I'll start again from the bottom of the lifter assembly with the ejector plates. We have our slide shoe, ball retainer. As I mentioned before, it's got a precision wired ball slot that's oversized so that the carbide ball on the left can move within the system and actually provide a float. We offer it in accelerated angles and decelerated angles, and it fastens to the ejector plates with socket-head cap screws. So depending on what the stack-up height requirement within your lift assembly is, you can mount it right on top of the actual ejector plate, or you can mill a pocket and recess it into your ejector plates. The carbide ball adapter, as I mentioned, is a two-piece construction. We use a proprietary process to solder that ball to the holder portion of that assembly. In addition, we have the dovetail feature. So with the dovetail, I had mentioned, it provides side-to-side motion in the auto alignment process, and that picture on the left better illustrates that. So moving on. Talk a little bit about the lifter rods. We offer them as an off-the-shelf product. Has a dovetail on one end. It's blank at the other, as you can see. It does require that you put some flats on to put the actual keeper key, within the system, within the assembly. As you can see in the picture there, we do show the rubber gasket again. The keeper key as it's assembled into the actual lifter blank itself. Moving on to the next one. So the actual lifter blade, as I mentioned, available off the shelf, has the dovetail feature again on the on one end. Here, you're cutting your part geometry actually within the blank itself. We mentioned the roller guides for added strength, and we do offer a wide variety of sizes off the shelves. Joe, in your experience, I don't know if you've ever used roller guides in lifter blade type applications. You may want to talk to us a little bit about that.
I have, Jeff, and I'm just sitting back thinking how cool this product is. I'm just excited about it again. What we're dealing with here, for the most part, on damaged old style lifters is thermal expansion. Now we've come up with a product here that has the carbide ball that's going to deal with thermal expansion in the X direction, we'll call it. We've got a dovetail that's going to deal with thermal expansion in the Z direction, or the Y direction. And we've got a gasket on top that's going to deal with thermal expansion in the Z dimension. And we also got these carbide rollers that are kind of optional. You don't absolutely need them with the technology we have today in our machining processes. The dimensions and the tolerances they're holding are so much greater than when I started out in this industry. So you could probably wire cut pockets, but then you're risking a wire cut pocket in your core block, your core insert, your BX plate, and of course all your manufacturing down in your the pin plate area and your knockout area, that I would personally put these carbide roller inserts in every product I had. It'll again take up some of that thermal expansion. It'll drive that dovetail to allow for your forgiveness that we're looking for and the auto alignment. And it's absolutely positively going to reduce or actually eliminate any galling that you have in your lifters. So we can go on, I think, from there.
Yeah, thank you. So this picture again is an illustration, custom lifter head with the keeper key, the rubber gasket. This application, like I said, very common within the automotive world. In addition to offering standard lifter rods, lifter blades, this system is easily customizable. The lifter, or should say the dovetail information, is available at dme.net. So if you have an application where you require a longer lifter rod or longer lifter blade, it can easily be manufactured. Moving on.
We're just going to show here, Jeff, an example of a larger lifter head, custom lifter head, that we're actually driving with two ACCUALIGN lifters, which is perfectly acceptable. And one of the things, again, I'm going to talk about is this thermal expansion. We're shooting plastic into this lifter head, this custom lifter head, upwards of 500 degrees. It's going to expand at a greater rate than your pin plates are, which is what your shoes are locked into. So the dovetail is going to forgive that expansion. And we're not going to experience the galling that we do now. I can tell you that when we run a mold in a tool room and on the bench, we'd have that thing running just slick as could be. And then as soon as production gets the mold, they put it in the press, they start squirting plastic, that thermal expansion starts up, and that insert is hotter than the pin plate, and it starts making noise. And they're going to say that our alignment's bad. Well, that's not going to happen anymore, simply because we have that dovetail, the carbide ball, and the gasket feature that's going to absorb, if for lack of a better term, that thermal expansion in all three axes. So I can tell you that oftentimes, if not all the time, your damage to your traditional lifters is going to happen at startup, at the time when that mold is not all the same temperature and your thermal expansion's happening, and that's when they're going to break and gall up and just make production a nightmare. I absolutely love this product. Let's go on.
Moving on.
Now we're showing my favorite slide of the whole deal. And I'm going to ask Jeff to be quiet just for a minute, because in my career, I have been stuck in the middle between designers and estimators numerous times as a project manager. If there's any project managers online right now, again, take this slide and make it your screensaver, because it's going to remind you of a couple of things. The ACCUALIGN lifter is going to take less space in your mold. If you're using side actions, you're going to have to increase your mold size. You're going to have to increase your press size. The estimators already quoted it, for lack of a better term, if you'll forgive me, with 10 pounds in a 5-pound bag. They're trying to put molds in smaller and smaller machines. The energy required to run them, the labor required to run the smaller machines, everything involved. We're trying to save money. And this product is going to allow us to make your molds compact. Not only will it make it more compact, there's a good chance if you're putting side actions to release the undercut shown in these parts, you're going to be in a custom mold base. DME offers numerous standard mold bases off the shelf, so you'll save money and you'll save time. You may even notice that these lifters in this particular slide are driven by one single slide shoe. Again, saving space. That single slide shoe, if it's not quite the size you need, call us, let us know. We'll work with engineering and we'll provide you with a wider slide shoe. We have material on the shelf ready to go that's not wire cut, and we can wire cut with the exact same precision that all our off-the-shelf products have, and they're ready to go. Time and money, time and money, time and money. That's what this slide will do for you. And maybe, just someday, the designers will get along with the estimators. We'll see. We still got work to do in that area.
And for these types of parts, this type of application, you can see here that we're using 2 lifters, as Joe mentioned, to shut off and form this part geometry. We mentioned also we offer a wide range of sizes. So we start off really, really small and really, really large for different applications. But in a situation where you might use an expandable core, they have their place, but sometimes they don't have enough expansion or provide enough travel to release this type of part geometry. So here's just an illustration of another solution where these lifters can be used. So thank you, Joe. Moving on. Slide cons. So slides are a commonly used mechanism to form side actions, undercuts. Unlike lifters, they're only used for external type applications. They take up a lot of real estate. So if you're trying to reduce a mold base size to fit within a smaller molding machine, these can prevent you from doing that. There's more components. They can be expensive. There's products that are available off the shelf. There's also ways to build them as customs with wear plates, gibs, a slide carrier, a slide face, horn pin, and heel block. And then if they do break, there could be a lot of expense going into that, trying to fix these, as well as downtime and all the other things that go into that. So moving on.
I won't even throw in if they break. I'll throw in when they
break.
I have replaced hundreds and hundreds of angle pins because many companies require their operators to wipe down their tools in production. They might have to reach in and clean a vent or something along those lines. And I can tell you that slides get moved and then the mold closes and that angle pin will be out of line and you'll damage the angle pin, you'll damage the slide. So this absolutely will reduce the maintenance. Again, the pros, less space required. We want to get it into people's minds. I wish it was more in my mind for years, is that undercuts on the exterior of parts doesn't automatically require a slide. We can use lifters to do that and get into smaller molds. There's less mechanical components involved to remove the undercuts. You may not think so, but starting adding up those slide components with detents and everything else and wear plates, simply less components. We can use the ACCUALIGN lifters to release interior and exterior undercuts. They'll be used as ejection. They'll help get your part off of the cores. The design flexibility that you're looking at on the slide here is limitless, absolutely limitless. Our engineering department can work with you if we get in on the start, and we'll show you how it works, and we'll give you all the details. And coming along, we're going to talk a little bit later in the presentation about something that's really cool. All right.
So just to do a quick recap, starting, again from the lifter assembly itself, from the ejector plates moving on up, we have our slide shoe, we have a ball adapter, and lifter rod or lifter blade assemblies, depending what the application calls for. Like I said, it's very, very customizable, available off the shelf, and can apply itself to a lot of different applications. Excuse me. I don't know if you want to comment at all, Joe.
Just that you're right, they are off the shelf at accelerated and decelerated angles, but if you have a part geometry that has to go off on a specific angle, we have the on-the-shelf stock available where we can wire cut that pocket with accuracy and send them to you at any angle that you would like.
Good deal. Thank you. Moving on.
And now we get into the cool thing that I just brushed on earlier. If you get this project into your system and get with DME early enough, we can get with you and design and build conformal cooling heads, the custom lifter heads. Cooling is just such a focus right now in the industry in part design and mold design that very soon, coming very, very soon, we will have lifter rods with cooling channels, and we can customize those cooling channels however you need it, and we'll work with you ahead of time. We'll work with your mold flow, and we can get these parts cooled. I'm really excited about that. Hot spots kill us.
And with our additive manufacturing and our conformal cooling inserts that we offer and provide, we can definitely provide some really unique solutions utilizing this system, like Joe was mentioning, for cooling situations. So moving on, questions and answers. If you have any questions, please forward them to scott_smith@dme.net. And with that, we're going to move into the next part of our discussion. So now we're going to talk a little bit about our DME Lifetime LT Series parting line locks. As most of you guys on this call know, there's all kinds of different parting line locks out there in the industry. The team here at DME, did some research, did some development, and looked and said, hey, where can we make a better product? We looked at materials, and we looked at manufacturing. And we developed this product. It's patented and made in the U.S. With that, we'll move into the next slide.
I don't know. I'm sitting here talking to myself, why are you so excited? Why the heck am I so excited about parting line locks? Well, I don't know either, but I am. Here's some reasons that I can tell you about. Number one reason that we should go with the DME Lifetime Series roller locks: initial engagement. Upon initial engagement, if there's any misalignment between your A side and your B side whatsoever, it's that initial engagement where the galling starts. Now, we have designed into the LT series carbide roller locks that are going to pick up the straight surface of the female portion early, and on the initial engagement, you're not going to get galling because the roller surface against the flat surface simply won't gall, and they're designed in such a way where they can be out of line quite a ways. We'll show you a little bit more about that later. Another big reason for the Lifetime Roller Series locks: early alignment. The industry is driving us to put in shutoff surfaces in our cavity and cores with less and less and less angles. We've got half-degree shutoffs shutting off against half-degree surfaces. Early alignment of the Lifetime Series roller locks is up to 30% sooner than your standard off-the-shelf parting line locks. So especially if you're getting into those sensitive shutoffs, you're going to want to use the LT Series roller locks. 30% is a lot when you're dealing with a half a degree shutoff angle from cavity to core. And the number 3 reason that I'm excited is something that we very, very rarely think about, and that is that mold moving under injection pressure? And so we've incorporated a triple and a penta patented design, say that 3 times fast, patented design, where our 2 inches and under parting line locks have the triple feature, and anything over that will have the penta feature. And what that does, it constrains the counter pressure of the injection pressure when that plastic goes into the cavity. So you're not going to change your wall thickness, and you're not going to get mismatched parting lines under injection pressure. You simply have more surfaces that shut off. They're stronger. They're the strongest in the industry today. And again, right next to and right at the bottom, they're made right here in the good old USA. All right.
Moving on. So how many on this call can go out into their shop floor right now, either see this condition on a mold on the bench or in the press, or have a bucket of locks like this that show this scoring? So this is metal on metal, galling, and then condition with you're trying to get longevity out of your mold. Eventually, this is going to be the same type of thing happening on your cores and cavities and telescoping cores. Moving on to the next one. So as a designer, sometimes you sit back and you're going through your design and different things you have to take into consideration. Thermal expansion, what kind of effect is that going to have? Not only on the way that the alignment happens, the way our alignment happens on the size of the mold being a smaller tool to a larger tool, so you're going to have fluctuations there. The leader pins and the bushings are only going to, provide your initial engagement, and different things you have to consider. Tie bars, the molding machine itself. Is it worn out? The weight, the actual weight of the tool within the press. In addition to auxiliary equipment, you might have an auxiliary injection unit, end of arm tooling, or some other things there that maybe you don't consider that are going to affect the way that your mold opens and closes and the final lockup, I'll say. So the solution, our tri-lock, with our triple lockup on the 5-degree shutoffs, in addition to the 5 or penta final lockup mechanism within our system here. So moving on, Joe.
All right, something that a competition just isn't going to even try. They won't even attempt. We tested our LT series side locks at a 5-degree angle, a 5-degree included angle, meaning that if your platen, your A side or your fixed platen can be up to 5 degrees off from your movable platen or the movable side of the mold, maybe a manufacturing issue. And we've designed these products to where you're going to hit carbide first before you're going to hit steel, even at 5 degrees. So when those parting lines come together, again, you're not going to experience galling. That picture we showed earlier, for anybody who doesn't know, that wasn't good. That's not what you want to see when you open up your tool and you find your parting line locks all galled up. The standard side locks, you couldn't even dream to begin to test at a 5-degree angle. So what we're showing here is that it'll just work better with the more problems that you have. We fill the gap, so to speak, between problems with A side and B side matching up and parting line locks bringing them home.
Deal. Moving on.
Parting line alignment, why do you need it? Why do you care? Critical dimensions, the dimensions that they're giving us now and the tolerances that the people are giving us now between the medical and automotive industry are just crazy. I'm sure everybody on this call has probably been stuck on that going, they want us to hold what? And a lot of that's being driven from metal to plastic conversions. The tolerances are easier to hold on the metal, and now we're working with plastic, and they're not willing to change their tolerances. So we have to do what we can to address it and continuously improve. So the critical dimensions that can be affected by misalignment of parting line, we just can't live with that anymore. And if your misaligned parting line, your wall thickness could be affected. If your wall thickness is affected and you got a thicker wall on one side and thinner wall on the other, the plastic is going to take the path of least resistance. At least that's what I found in my career. So your flow rates are going to change. And if your flow rates change and you got that happening, that path of least resistance, the end of fill location can change. And if the end of fill location changes, your venting could change. And if your venting changes, we've all had experience with short shots and other various defects. I think the venting could probably be a whole nother webinar, Jeff. We can talk about
I
that
agree,
later.
absolutely.
But you want to wrap this slide up?
Yeah, so as we mentioned, like in the prior picture that shows the wear starting within your locks, I mean, that's eventually going to migrate up to your standing shutoffs and your cores and cavities. So parting line alignment is very essential to longevity of your mold, essentially. So the type of lock that you install is going to reflect on quality of part and longevity of your tool, especially in a high volume type situation. So moving on.
All right, what we're showing here is it's time for me to confess that I'm a tool maker, and tool makers and quality departments normally never shall meet and never shall agree, but I actually spent a couple years of my career as a quality manager. So I got to know a few things about continuous improvement, because I'm guessing that every company that's represented on this call right now has a continuous improvement team, along with DME. And that's what this slide is trying to show you. We have parting line locks that have been in the industry for years. They're great, great products. But the customers and the industry is demanding that we change and continuously improve. And that's what we're doing with these side locks today. We're showing you on this slide that we've changed to some high temp material, which is going to last even longer. And if we want to go to the next slide, we can talk a little bit about the 440 stainless and COVID-19, how that's driven us to this. Jeff?
Yeah, a year ago, and the COVID medical PPE applications hit us really hard. We didn't have, or the industry didn't provide an off-the-shelf stainless type lock. So the team took a step back, looked at it, and we used our LT roller lock design. We used the 440C stainless, which is used in ball bearing material, used in different parts of the automation industry, and we created an off-the-shelf stainless lock. So for clean room applications and long-term medical type applications, we provided a solution. Also in situations where you have maybe multi-shot type tools, this is another option for you as an off-the-shelf stainless steel lock. So moving on.
Just a little bit more about the testing that we put through these locks. And we talked about the 5 degree. That was done in a lab. We set up a 5 degree angle. We didn't intentionally screw up a tool and go put it in the press and close it up at 5 degrees. So in the lab, we experienced over 2 million cycles with that 5 degree fixture with virtually no wear. Grease was still evident after 200,000 cycles. And we did have a tool in the field that ran 14 months straight at a fast cycle production rate with over 2 million cycles. None of those locks have seized up or shown signs of galling. None of them have fractured, and they didn't need to be repositioned. And reposition is just an old trick in the trade that some people might not be familiar with. But if they get galled up on one side, and sometimes you just take them and flip them over to the other side of the mold and try to use a faulty lock to continue production. We don't recommend it. We absolutely recommend that you consider the Lifetime Series roller locks. Patented technology, and one more time, made in the good old USA. Once again, I'm just going to reiterate, if we go to the next slide, the first big reason, the carbide roller bearings for a smooth entrance from A side to B side to reduce or eliminate the galling on initial engagement. Number 2, the 30% earlier engagement, which is going to allow you to save those cavities and core inserts that are shutting off on each other. When I started in this thing, we wouldn't have a shut off at less than 3 degrees. We just wouldn't do it. But where we're at today with the technology today and the demands today and the customer demands, We have to. And so this 30% earlier initial engagement is addressed exactly to that, those customer demands. And number 3, something that we didn't think about much at all in the past was lockup while we're in production, while that plastic is shooting into the tool, and any misalignment that's happening and movement that's happening under injection pressure. That's why we've added the additional surfaces for lockup, the penta and the triple locking configurations that we're showing here. They're simply the strongest final lockup in the industry. All right, I think Jeff's going to do his share of recap now.
Yeah, as I mentioned before, with our stainless steel, we also offer a high temp version of our LT lifetime roller lock. We cover a lot of, well, I should say we cover all applications as off the shelf. Looking at the picture on the right, you can tell our competition's lagging in this area. So with all the different parting line options that we offer as well as solutions, we got you covered. Moving on.
One more time, if any questions during the webinar today, we'd like them to be addressed to Scott_Smith@dme.net. You can type your questions and we'll be addressing those this afternoon and in the days to come. And we'll be able to answer any questions you have. If we can go to the next slide. You can also find all your answers at dme.net, the go-to place for solutions for injection molding. You'll find on that site CAD data. You'll find on that site return on investment forms and information, product guides, part lists, CAD models for mold bases, those mold bases that you're reducing the cost on. All the off-the-shelf mold bases at DME have the CAD data available. Got to slow down. Too much coffee, I think, this morning. Anyways, go to the next one slide, and I'm going to talk a little bit about resources. I said earlier that I've been doing this over 40 years. I thought I knew a lot. I started with DME in January, and I found out they truly do have a world of resources that I was simply unaware of. DME.net has been upgraded in the last year to meet those demands of answering your questions that you have during this webinar. Virtually all the information is there on any product that has anything to do with injection molding. We call it from pellet to production, and everything in between is available at dme.net. Simply is a world of resources. And after dme.net, you can simply click on the Shop eStore button, which is on there, and that'll bring you can type in ACCUALIGN lifters, and you can search on the name of a product, and it'll bring up a screen just like this. And then you can click around on this screen and it'll show you availability of all our products. It'll show you the sizes available. We have these products available in a multitude of sizes. Right now, as you can see, they're all in stock. It'll give you your cost for the ACCUALIGN lifters. And it's as simple as clicking on these, adding them to the shopping cart, putting in a purchase order number, and you're done. We'll ship them the next day. Another thing that we have on here on the eStore as well as DME.net is design guides, brochures that you can print off right now, bring them to your boss and show them how much money you're going to save on your next tool. And the CAD data is available also at the eStore and at DME.net. Jeff?
Yeah, just to recap what Joe said, in addition to the ACCUALIGN lifters, all the LT Series lifetime roller lock information is available at dme.net. Here we offer many, many different types of solutions, not only for the locks, cooling, undercut solutions, alignment solutions, and everything available in native CAD formats as well. From that point, we pretty much have all the popular platforms offered. And then moving on, in addition to the eStore, as Joe mentioned, when you start your quoting process, you can access, in a matter of seconds, pricing, availability of our components, and get moving on your quotes. With that, Joe, you want to wrap it up?
All right. mainly, Jeff, what I want to do is I want to thank you for being
Thank
a
you.
part of this webinar. I want to thank DME for putting the confidence in the new guy and letting me show my excitement. I want to thank the participants who showed up today. Without you guys, it wouldn't really be worth doing much here, would it?
Yeah,
And I'm going to thank my boss and our producer and director, Scott Smith, for putting the confidence in me and letting me be a part of this DME series of webinars, which we hope it to be a series of webinars. This is our first one, and you can watch for the next one coming soon. Thanks again, everybody.
Yep, thank you, everybody. Hope to see you next time.